Welcome everybody to Jozi-JUG. This is our first online event since pre-COVID. So we haven't had, no, since COVID actually, because lockdown we only did in meeting, like virtually, so we couldn't meet in person. So welcome. Without any further ado, I would like to introduce you to Csilla. So Bruno suggested that she comes and talks to us. So, and I said, cool. We need more brains, people who are smarter than me to come and give the talk. So she's a professional software engineer, and then she will tell us how to build our career path or using Java. So Csilla, if you happy to take over so that, you know, and everybody can learn from your brilliant mind. And you're from Switzerland, huh?
Yes, I am from Switzerland. So actually, I live in Switzerland, and so thank you very much for the invitation, and good evening, everyone. So my name is Csilla, and I'm very happy to be here. It's an honor, a pleasure for me to be able to present here this little presentation. So actually, I hope you can hear me well, so there won't be any technical problems. So let's jump into it. A few months ago, I had to give an company internal presentation during this about any topic, and I knew that this is a very Python-heavy environment. So the people usually are programming in Python. So that's why I chose a topic to talk about Java and AI. So a little bit of provocation just to show people that what you can do in Python, it is nowadays it's also possible in Java. While preparing for this presentation, I was looking at a template that I found at the working group of the GCP. At that time, I was a little bit embarrassed because I didn't know very well what is the GCP, what they are doing exactly. And also, I knew what the JEPs are, but I didn't know how things are connected exactly together. It was a bit of embarrassing situation. And if you are looking at the site of Oracle where I tried to find more information, now I also had a little bit of problems. So let's, I try to share my screen right now. So I hope you can see because I don't see.
I can see your screen.
If you can see, that's very good. So if you are looking at here, so those are the official Oracle pages, and describing what the OpenJDK is, what are the JEPs. So everything on this site is very well maintained, correct information, but still it was not clear for me how things are connected to each other. And then I got a tip actually from Bruno, who said, why don't you connect Java and data visualization? So you try to visualize Java's evolution and all those concepts so that we can better understand it. And actually, that's what I did. After that, And I hope that this visualization can help us to understand those concepts much better. Because if there is a way that we can visualize how Java is being evolved, what's coming next, if there is a future, then we will be probably, hopefully, see some ways where we can see opportunities to grow professionally. Now, of course, you can. That's also the reason, because you probably would ask, why should I care about the whole ecosystem, about terms like JEP or GSR? And after the presentation, I hope that you will get the answer why it is good if you can connect the dots together. So before we start, maybe very shortly about the concepts that I think that everyone knows here. So the OpenJDK is the implementation of Java, the Java platform. So this is the actual code, and tightly connected together are the JEPs, like here also, those are the JEPs here listed below, that are basically, they represent features that are being introduced in that OpenJDK release. We will also talk about GSRs. Actually, the JEP is the abbreviation for the JDK enhancement proposal. And the GSR is the Java specification request. It's basically the specification that specifies exactly how what should be there in Java. And we also have the GCP, the Java community process. This is the process making sure that the Java community is also involved in the evolution of Java. So after this introduction, I think we can start looking at all those concepts. So this is just the beginning. This is the same thing that I described before, that those are Oracle's official pages, well-maintained pages, but still a lot of dry information here. So how can we visualize it in a different way so that we can understand it better? So let's imagine that every JDK is a star like this one. And you know that Java started in 1995, so over 30 years ago. At the beginning, when Java was introduced, then you had to wait many years until a new version came out. So there were huge gaps, years between two versions. You were impatient to see the new version of Java. And when it was there, then all of a sudden you were overwhelmed with all those features that were introduced. So you had to learn a lot. And you did not know exactly what's going to happen. And after a while, people were thinking about if there's a better way to introduce new features. There's a better way to make new version. And this is when they invented this 6-month cadence, which means that after 6 months, no matter what, you will get a new Java version. And this Java version, so it is, of course, with less new features than before, because you only have 6 months for development and testing. But you can make sure that there is, no matter what, there is one new version. So this gives a kind of regularity. so you have this new version, and it can happen because the time frame is very short, that there are features that are fully implemented, but there will probably be also features that won't be finished. So they are still in development, but you will get a chance to look into these features, try them out. So this is kind of change that happened. So this is why I introduced two more stars for after we have this 6-month cadence with the orange stars. There are two different JDK, as you know, the normal version, which is an empty star. Those are the normal JDK versions that are valid and supported until the new JDK version is coming out. And the long-term support version, here indicated by a full star, is the version which is supported for a longer period of time, until the new LTS version is coming out, usually after 2 years. So that's the difference between the two of them. And this is just a visual distinction, how we can imagine all those JDKs. As I mentioned before, the JEPs are tightly connected to the JDK because they describe changes to the Java platform. Usually they describe new features, what people would like to have in the language. So people are just proposing new features, and JEPs are also a very good way to track what's happening, what is the status of the development, because they have got a kind of life cycle themselves. So JEPs are usually indicated by a number, by the JEP number. And because they are so coupled with the JDK, we can imagine JEPs are like they are just surrounding the JDK versions. Also, a lot of times people maybe don't know what the JEP number means. In that case, instead of a number, we can also use some kind of description for the JEP. So now we know the basics, how I imagine this representation. So let's see Java's evolution more on a timeline. So this is what we can find here. Over a timeline, that means we are starting with JDK 10. This was the first version after the introduction of the 6-month cadence. And right now, the JDK 26 is selected because this is the currently supported actual version. And for the selected JDK version, you can see here what is in there. If we hover over the star, then we see some basic information about the JDK. When it came out, it's not a long-term support, not an LTS version right now. You see all the JEPs that are being implemented for this JDK version. Hovering over, there are some more metadata information. State is some internal state which tell us more about whether that JEP is still in draft or already targeted for a new JDK version or has already been implemented. But for us developers, it's not that important. It's important for the people who are really developing OpenJDK. So it is important to know for them where is the stage of the development. Here you will see that there are two kinds of JEPs. Those are the full JEPs. They are basically features that have fully been implemented and specified, implemented, and they are already permanent part of the of this JDK version. And the empty JEPs, they are the JEPs that are still might be in development, so they are not permanent yet. They can be like here, the vector API, they can be in incubator stage, they can be preview, or they can be experimental features. So you can be sure that they will be 100% for sure that they will be included in that version, because based on feedback from the developer community, it can happen that they just forget about it and they won't include it in the final JDK. And this is also the reason why they are not switched on per default. So if you are installing a new JDK version, you need to switch them on explicitly if you want to use them. But what is encouraged here, it is encouraged to try them out, because the developers are really relying on other people, that someone tries out these features and gives them some feedback, whether how they behave in their own environment, what is functioning and what is not working. So that's why it is also important for the community, for us. There is the opportunity, of course, that you can try out the feature in advance before it gets finalized. Now, in this picture, you see the JDK, the JEPs, but there is something invisible here in this view. This visualization does not show little changes, enhancements, bug fixes, or performance improvements that are also included usually in new JDK versions. And there can be several such changes. So I heard once that there can be several 1,000 such changes that are basically bug fixes or improvements. They are all tracked in Oracle's own bug tracking system, but because they are not significant enough, they are not big enough changes, that's why they don't get a JEP number. And they are not seen here, but they are integral part of the new version. So this is the invisible important information, just to know. If we would like to have an outlook what's coming next, in September, the JDK 27 is coming out, and we already see that there are some features that have already been finalized, and there are some other features that are in preview here, for example, and vector APIs will still be in incubator status. Here we can see what was in JDK 25, and I know that in JDK 24 there have been a lot of JEPs. Here you can see it's much more. So this view is really to play around with Java's evolution to see what's being introduced. Now, here there is only one JDK visualized at once. There is also the possibility, what about if we try to visualize it, everything at once? So this is what comes next. So let's see this whole Java universe together. In this view, you can really imagine the evolution of Java. All the JDK versions, since the introduction of this 6-month cadence, you already see that JDK 28 is coming out sometimes, but there is only one JEP which is foreseen for this version right now, but it can change at any time. So those big circles are the JDKs, and in there you have got those little circles which are the JEPs altogether. I think it's a relevant view to get you a better understanding what has been done since in the last couple of years. So there is a lot of going on in Java. Now, usually if you are talking with other people, then they might not talk about specific JEPs, but they will talk about projects with you. So projects are something bigger. So usually if people have got some bigger ideas, then they would like to implement these ideas, then those ideas are usually too big ideas. So you cannot put it into one JDK to visualize it. But it's best that I am showing you this view so that you can better understand what I am talking about. So projects are some informal constructs of OpenJDK, so they are not official. And if we are looking at Oracle sites, usually the project sites are not that well maintained at the moment. So there are some projects that get a lot of description. You also have a list of JEPs that try to implement all those IDs. And there are also project descriptions where you barely find any information. But here, the idea is still trying to show what's going on in those projects. Right now, Amber is being selected. The project is about making you as a developer more productive. So it's about language features, constructs, that if you are using them, then you can be more productive, write better code. And here are all the JEPs that belong to that project. Again, there are some that have been already finalized, are permanent parts, and there are some other JEPs that are still being developed. If you would like to see another project, then we can just switch over to Valhalla, which is about the value types. Here, there is also some work going on, and I think this last JEP is quite new, so still not connected to any JDK. Valhalla and value types is also about reducing the gap between primitive types and objects. and better performance, which is of course needed if you would like to prepare Java more for AI tasks. And Panama is more about making Java really work well in for AI tasks, because it is also about, there are basically two main features that people are working on here. The first one is here, the foreign function and memory API. And the second one is the vector API, which is still in incubator state. So the vector API is more about that. With that, you will be able to make numerical computations much more performant. So it can speed up a lot, which is needed if you're doing machine learning. And it's also about how you can call native code from within Java. Of course, it was already possible in the past with GNI, but right now, this new way is the preferred way to do it. There are some other projects as well. It is just a small selection of, really a small selection of all the projects that are possible, that are currently existent in Java. So there are a lot more, of course. And Loom is a project that it's about the virtual threads that have been introduced, and that makes hopefully your life much easier. It's easier to program such concurrent situations. Right now, it's much clearer, the code, what you can achieve with that. Leiden is the next. It's about reducing the startup time of Java applications. And there are some more where we still don't have a lot of defined jobs, like Babylon or Detroit. These are new projects. So there are, of course, a lot of things going on. And if you paid attention, then you saw that, for example, here, if I can demonstrate it on a Panama project. You have got here Vector API, 8 incubator, and then you have got Vector API again. So you have got the same feature with 2 different chat numbers. And it means that they mean the same feature, but implementing this takes a lot more time than just 6 months. And the feature is the same, but for each JDK, they are getting a different chat number. So this is the difference. This is also for you just to look around, to play around what is in there, so to understand Java much better. Now we talked, of course, about how JDKs and jobs are related to each other. We saw that there are a lot of jobs that can belong to projects, but what we didn't talk about, that those jobs can also be related to each other in a way, because like here in this situation, they are the same features, or they are related to each other, but it can also happen that one job is dependent from the implementation of another job, or one job is blocking another job. So, of course, there are some relationships between them. And I think it is quite interesting to have a look on this. So that's why we are having here another visualization form to illustrate it much better. So in this extract, there are only two features with a lot of checks, of course. And one of the features is the vector API. In this view, what's interesting to see is that they started with the implementation of the vector API somewhere here at JDK 16, and all over the way, it took a lot of time. JDK 25, and even with JDK 27, this feature will not be finalized yet. This kind of view, but this view represents all those relationships because they are really very tightly connected to each other. It's the same feature. So it's interesting to see this history, what's going on. If we are selecting another one, like here, foreign function memory API, which is also part of the Panama project, and we can also recognize they started development a long time ago. And then it has been finalized in JDK version 22. So a lot of time. Now, I hope that you understand right now what I try to illustrate, how things are connected to each other, so that we are able to see right now the whole Java galaxy. This is here. Here you see all the JDK versions from JDK 10 on until JDK 27, which is here. It might happen that that you cannot see that very well. So let's try to make it a little bit larger so that you can read it better. This view makes it also possible that you can walk around a little bit if you would like to explore what's going on. You can, of course, click on something different and then see all the connections, how things are related to each other. And also structured concurrency is a feature that has started a long time ago in JDK 20. And if you are interested what is in JDK 20, then you just click on there. Again, I need to make it a little bit larger so that you can better read it. This is really the view where you can play around looking at those features. So this is interesting to see, but let's go back for a moment. If I select some, let's say I am selecting maybe JDK 25 here, right in the middle. Then here, what I was not talking about it until now is that every JDK, So the implementation is always associated with a GSR number. The GSR number, so this is a 101 relationship, because what does it mean? Java, the Java platform is not only open source, but it is also open standard. So you have on one hand side, you have got all the JDK, the JAPs, which is the implementation pillar. But you have got a second pillar in Java, which is the specification pillar. And this GSR 400 is the so-called platform specification. And it specifies exactly what should be in there in this release. It does not specify implementation details, but exactly what should be part of this new version. So OpenJDK is basically the reference implementation of this platform specification. And it also proves that if you have got a really good specification, then there is at least one implementation, the OpenJDK, which implements these pets, so the specification itself is working and is valid. And how people develop this specification is where the GCP, the Java community process, comes in. You can be a member of GCP, but also even without being a GCP member, you get some more information what you can do. For example, you are able to review or read such specifications and give your feedback on them. So the GCP is the organization that's making sure that this process around the specification, how the specification is created and goes through a whole process, that this process is open for everyone in the community, and it's making sure that the community can provide feedback on them. So the community gets the chance to look at the specification, comment on it, and there is the GCP Executive Committee where they vote on this specification and they accept this specification. So they don't make the specification, but after the process, they vote on it. And in this executive committee, maybe there are 20 members. There are companies, vendors in there. There are also some Java user groups represented, like SoJava. Also, there can be individuals part of this executive committee. But what is important here is to notice that you have got one reference implementation for this specification. And in this specification, those companies, those vendors have also a word. So they bring in their IDs, and because there is a specification, it gives them the possibility to implement as well. So that's why you have got so many implementations in different implementations in Java, like I'm not sure what you are using here, but Oracle has got a JDK, then you have got from Amazon, Eclipse has got one, Temurin, Red Hat has got one. So there are a lot of implementations, which are, of course, different from each other. There is one common thing in them, that they implement the same specification. And because of this, they are, in a sense, interchangeable. So your Java application, which is running with one distribution, should also run with another distribution. And here where this technology compatibility kit, so TCK, comes in, this is a set of tests. Because if you are implementing such specification, then you have to prove or if your implementation is compliant. And for this, those are the tests, and all the tests need to be passed. And if all the tests are passed, then you can say, okay, I have an official Java implementation. So all those distributors are, of course, concurrents, but also they are working together on these specifications. So this is interesting to see in all this Java universe. And now we can come back to the original question of what you might have asked yourself. Why should you care about all this JET and GSR thing? This is too complicated, maybe this is too abstract. But if you are a senior Java developer in your company, then you might have a lot of possibilities to work on really cool projects, but somehow your influence might be a little bit limited. And if you would like to have a bigger influence, a bigger impact, not only within your company, but also outside within the Java community, then there is a chance you have got opportunities where you can work on the evolution of Java. And with this, it is possible that you can influence the life of many more developers. So I don't know the exact number, but I heard something about maybe 12 million people on the world are Java developers. I'm not sure if it's the right number, but maybe more or less. This gives you an idea on the impact, what you can have here. What kind of impact? Of course, because OpenJDK is, for example, open source. You can contribute to open source as an open source developer, but even if you are not contributed directly to OpenJDK, by looking at the code, how people made design or architecture decisions, you can learn a lot from it. Another possibility is to give people feedback. What we mentioned already before, I mentioned this preview or incubator features. If you are experimenting with that, you can write back if your feedback, your impressions, your experience, that people there, they appreciate it very much. You can also go into the on the specification side and look at those specifications and try to understand, comment them, and in this way you are really directly involved in the evolution of Java. But even if you don't go so far, maybe you would like to share your knowledge, give talks. And usually what I saw many times, that people are interested in talks where people are saying, oh, Java 27 is coming out in a few months, so what's new? What are the new features? So let's talk about the new features, what they are, how you can use them. So this is one favorite topic, what I see quite often. Also, there is another interesting topic for you if you would like to see compared to different Java versions. Let's say you are still on Java 21, and then you ask yourself, oh, does it make sense to upgrade to Java 25? What are the benefits? What are the differences between those two different versions? So those are also very popular topics. So this gives you, if you see all these processes, how they work together, this implementation, specification, and you understand all these processes a little bit better, then you will see these opportunities, possibilities where you can really share your knowledge or contribute more to the evolution of Java. So this is basically the last visualization what I wanted to share with you. And of course, if you would like to play around a little bit with this visualization, then I made here a QR code where you can just jump to this site and play around yourself a little bit if you want to experiment with it. So if you have a chance or if you have got time for it. And now with the end of this presentation, I'm just curious if you have got questions about, or if you have got any comments on this.
Yeah, there's one question from Paul, and he said, have you made any contribution to a JEP yourself? If so, what has your experience of the process been?
Right now, I didn't make my own contribution yet. I am exploring all these kind of topics, what's possible. My contribution at the moment is understanding how things are working together, and I am providing this visualization for people to understand the topic better. And maybe at a later point, I can do more, because every individual can just go there. So it's possible. Honestly, I don't have that experience with that, providing, going into the specification or being contributing to OpenJDK, but this could be possible.
This video will publish this on our YouTube channel. So just look for Jozi-JUG on YouTube and you'll see the same logo, and then subscribe and all that good stuff so that you will know when I've uploaded this video. But then on top of that, thank you for coming, and I'll see you guys on Wednesday.
Thank you very much for the opportunity, and thank you very much for your attention. And I enjoyed it very much, so thank you.
All right. Thank you. Have a good one. Cheers, everyone.
Thank you.